In this video, we're going to look at the remaining quantificational concepts and what can and can't be shown with interpretations. So, a set gamma of sentences of PL is quantificationally consistent if and only if there is an interpretation on which every member of the set is true. And if there is no such interpretation, then the set is quantificationally inconsistent. Um, no single interpretation can show that a set is quantificationally inconsistent because this is something that depends on what happens on every interpretation, right? It's inconsistent if on every interpretation, at least one of the members of the set is false. But you can have a single interpretation that proves that the set is consistent. You just need a single interpretation on which every member of the set is true. So here's an example of constructing an interpretation that shows that a set is quantificationally consistent. We'll take this set with these three sentences. We'll give an interpretation on which all of them are true. We'll use a simple mathematical example for this. So the universe of discourse is positive integers. We'll interpret n as meaning that x is less than y, and m as x is greater than or equal to y, and then a will be the number 2. So if we go through the three sentences in order, right, there is an x and a x. What this means is there is a positive integer that 2 is less than, and that's true. There are a whole bunch of those. There is an x such that not max. This then means there is a positive integer that 2 is not greater than or equal to. That's actually just this, right? There is a positive integer that 2 is less than. And so this is still true. And this last one here, every positive integer is less than 2, or it's greater than or equal to 2. I mean, that's true for every number. So obviously that's going to be true for 2. So all three of these sentences then turn out to be true, which means that the set is consistent. So we've proved that with a single interpretation. But of course, we couldn't prove that it was inconsistent just by coming up with a single interpretation on which one of the sentences was false. That doesn't prove that at least one of the sentences is false on every interpretation. Okay, next is quantificational entailment, right? A set gamma of sentences quantificationally entails a sentence P if and only if there is no interpretation on which every member of gamma is true and P is false. And we still abbreviate this the same way with the double turnstile. I mean, you could in principle put PL in subscript underneath this, to show that what you're talking about is quantificational entailment and not truth functional entailment. But really, I mean, you'll be able to tell that by looking at the sentence and seeing that this is a sentence of PL and not a sentence of SL. So that's not actually necessary. As with SL, validity is defined in terms of entailment. An argument is quantificationally valid if and only if the set of the premises quantificationally entails the conclusion. Now, entailment is another thing that you can't demonstrate with a single interpretation, right? Because it depends on what goes on with every interpretation, right? It says that on every interpretation, if every member of gamma is true, then P can't be false. And you can't give a single interpretation that shows that. But you can give a single interpretation that proves that a set doesn't entail a sentence. This is just an interpretation where every member of the set is true and the sentence is false. So here is an example. We'll give an interpretation that shows that this set, that sentence in this set, does not entail this sentence here. Let me use a non-mathematical example for this. So the universe of discourse will be members of parliament, and then we'll interpret A as meaning X likes Y. So this first sentence here, right, what this says is then for every MP, there is some MP that they do not like. And this has got to be true, right? I mean, you have political rivalries. You've got the fact that a lot of MPs are just sort of unpleasant people. You've got grudges. Parliament is big. A lot of them probably just haven't met, have never formed an opinion of each other. You know, I mean, the sort of person who genuinely likes every other human being is probably just not going to survive in politics very long. It's more the type who can give you a great big smile and shake your hand, while they're imagining punching you in the face. Those are the sorts of people who tend to survive well in politics. The conclusion then is for every MP dislikes themselves. This is absolutely false. I mean, half of them are pathological narcissists. You know, what most MPs need is to sit down and eat a 16-ounce slice of humility with a side order of sauteed dude. You are not the center of the universe. But I digress. Quantificational equivalence. So two sentences are quantificationally equivalent if they have the same truth value on every interpretation. This is another thing that you can't show on or with a single interpretation, right? One interpretation where they have the same truth value does not show that they have the same truth value on every interpretation. But if you have a single interpretation on which they have different truth values, then you can show that they are not equivalent. So here's an example. We will show that these two sentences are not equivalent. Now, the tricky part of coming up with a counterexample to equivalence, the tricky part is always this. One of the sentences may entail the other. And if that's the case, you're not going to be able to find an interpretation where that sentence is true and the other one is false. So before you start working on like trying to find an interpretation to show that two sentences aren't equivalent, you need to think about what they mean, and you need to think about whether one of them is likely to entail the other. So this one, this is a categorical sentence, right? This says all F's are G's. This says here that if there is an F, then there is a G. So if you think about these, right, if all F's or G's are true, then this also has to be true, right? I mean, if it's the case that all F's are G's, then if there is an F, there also has to be a G, right? The same thing that is an F is also going to have to be a G. So you're not going to be able to find an interpretation where they have different truth values by setting this is true and this is false. But you may be able to go the other way around, make this one true and this one false. And you can, in fact, construct an interpretation that does that with the help of this guy again. So we'll set the universe of discourse as animals. F will be X is a yellow-bellied sapsucker, and G will be X is green. So the first sentence then means all yellow-bellied sapsuckers are green. This is false, right? As you can see. The second one is if there is a yellow-bellied sapsucker, then there is a green animal. That's true. Yellow-bellied sapsuckers are real things. I did not just make that up. And it's also true that they're green animals. So true antecedent, true consequent, which means that this conditional is true and this is false. So these are not equivalent because there is at least one interpretation where this one is true, or one of them is true and the other one is false. So those are the remaining quantificational concepts, and that's what you can show with them regarding or using interpretations.